Hey, hi everyone. So, in the previous lectures, we had discussed about MLflow tracking, how to create experiment, how to track experiment, how to do multiple runs under experiment, and how to run multiple experiments also along with multiple runs. Now, I think in the very first video, I have showed you there is some visualization that we can do, right, to understand that which parameters are performing well on my data set. But that was a really basic, just one time I ran that code and only one time I've showed you some visualization. But that doesn't make sense, right? Because you are not getting any proper view that, okay, how do I really use it, right? So in today's video, I will start with that. So today, under one experiment, we will run multiple runs. Okay, so under one experiment, we will run multiple runs, and then we will see through the visualization provided by MLflow. We will try to understand that which parameters is working well in my scenario, right? So this is the code, right? Multiple parametrics logs.py. This is the last lectures resources that I am referring right now. And what I am going to do now, I am going to copy the same code to show you today's video. So for that, I will again create a new file MLflow multiple runs.py. Okay, and I'm pasting the whole code here. Okay, I have pasted the whole code here. I will do the toggle word wrap to make sure we are able to see everything properly here. Okay, so things are good here. Now what I wanted to do, see, if we come here I was using some fixed random fixed n estimators, fixed random state values, right? But now what I do, I will take some range of n estimators and I'll take a range of random state. What does it mean by range? Range means list of elements. Like I will do maybe n estimators equal to range 1 comma 30. Okay, and random states equal to range 1 comma 30, same. So what I am doing, this range 1 comma 30 will create a list of element starting from 1 till 29. The last one will always be discarded. Okay, so now what is going on, that we have n estimators, the list of elements, random state, list of elements. Now what I do, I run a loop on top of it, and I will keep on using each and every n estimators and random state values, and I will try to understand then for which two of the parameters my model accuracy is going so high. Okay, so that you will get the understanding that how do you visualize in the real scenarios. Anyways, in the next upcoming lectures, we will do an end-to-end project where we will do the same thing again. But before that only, I just wanted to show you how things work, so that when we do the end-to-end projects, you will get a better clarity on top of it, right? So let's start. So for that, I will start running a loop. I will do estimators and rand states. Okay. Then what I do, I run in a zip format. N estimators and random states. Okay. Why I'm running in zip format? See, I will take parallelly, like this n estimator value plus random state value. I'll let me explain first of all. If you don't understand what did I mean, 1 2 3, let's assume that I have two lists. 1 2 3, let's assume that I have two lists. Okay, so focus on these two values as of now. Okay, so when I run a loop in a zip format, that means in each loop, in each iteration, it will take these two values. In the next iteration, it will take these two values. In the next iteration, it will take these two values. So parallel, it will take two values. That is why we apply zip. Okay, so that in parallel, I can take two values, n estimators and random states. Okay, that's what it means. If you don't understand, please ask in the comment box or some resources section in this graphy page. We will definitely help you out. Okay, now, so this is the page, this is the loop. Now what I do, I'll try to keep this whole code inside this loop. Okay, this is the whole code I kept inside the loop. Now my estimators will be this estimator. So I'll take this estimator, replace it with here, and this is the one I replace it with here. And now I'll take it from here. I'll do params, then I'll take the n estimators. And the same way, I will do params and I'll take random state. Okay, so I'm taking this value from here because anyways I'm appending these values inside this dictionary, right? Parameter dictionary. That is why I'm doing that. Okay, so code will be same. I'm not doing any other changes in this code except I'll try to comment this one because this is not required in our scenario, right? So it looks good to me now. Okay, it looks very good to me. Now what I do, let me explain you what I do now. Yeah, see, I hope you can recall this code was returning the last active run details, and that's what I was printing also, the run ID, the run URI, right? Now to understand in our console that things are running properly, I'll try to put a print statement here, okay? Like this kind of print statement. To understand that my runs are completed, okay? Because 30 times it will run almost. So 30 times we should be able to see this one so that we will understand that, okay, loops are working really well, right? Okay. So now what I do, I will first try to copy this path and I'll try to come back to this path. So let me come back to my path in my terminal. This one you guys don't have to do. It is like I have activated one environment from one of my project. That is why I am doing it, but it is not, you don't have to do. Okay. I think we are good here. I think this is also looks good to me. Okay. We are all in a good page. Okay, fine. Let me check if I am correct one. Okay. Acha. I need to go inside this MLflow one also. Okay. Yeah. Okay. Things looks good to me now. So now what I do, I will first run my MLflow, right? I first have to run the MLflow. And another change we need to do. Let me explain what change that I want to do. Okay. See guys, let me show you another thing also altogether so that I can explain things to you very early and we will understand things. Okay. See, in the previous sessions, I have showed you how we keep all the experiment details, experiment metadata, run metadata in a folder, right? But now what we do, we don't keep in a folder. But in a real scenario also, right, you don't keep things in a folder. You keep things in a database, correct? And in our laptops, SQLite come installed by default, right? So now what I do, instead of saving those experiment metadata, run metadata, storing in local folder, instead of that, we will store inside a database so that you will get the understanding that how you can do that also, because when you do the real scenarios you will keep things inside your database only, right? And later we will see how we can keep things on S3 bucket also on AWS cloud, that also we will see, but not now. When we come in the cloud section, there I will again show you the same thing, so no need to worry on that part. Okay, so now see, so for that I need to start my server, correct? I need to start my server. So for that what I do, MLflow server, okay, MLflow, so dash backend store URI, then I will pass my SQLite name. So this is the SQLite, this is the way you need to pass it, okay? C/s, yeah. Then the name of this database I am giving demo.db. So MLflow server, that's just backend stored URI. That means in the backend it will store all the information, all the experiment details, all the runs inside this database. Okay, that is what it means. So if I run this code, as you can see, it's loading things up. And if I show you inside this folder, can you see demo DB is already created for us, right? But it won't be having any content. Okay, just to prove my words, if I come here and if I open that, because server is already running, if we come here, see there is no experiment, only default experiment is there, that already I have told you. By default this MLflow creates default experiments, okay, but there is no other experiments we have in our scenario, correct? Fine, that means we are good here. Now now my question is, I am running all this. See, now one change I need to do. See, can you see the set tracking URI, right? So in that sense, I need to change the tracking URI. So which URL I am referring right now? I am referring to this URL, right? So I will try to copy the path of this URL and I will try to keep that URL there. Because if I don't do that, it will keep on referring this ML testing folder. It won't refer that database that already I have given, right? If I give this URI, it will understand that it has to focus on this URI, and this URI is connected with a demo DB. Okay, this is a SQLite database. Instead of SQLite, you can connect MySQL, Postgres, any other DBs also. I will show you, I think, MySQL or Postgres when you do one end-to-end project, but not right now. Let's do for SQL DB as of now to get things simply. Okay, so things good to me now. Now what I need to do, I need to come back here and I need to run that code. Python MLflow multiple runs dot py. Acha, okay, there's a name issue. It's not MFlow by default. By mistake, I MFlow I have written, but let's keep the same name only. MFlow multiple runs dot py. If I run this code now, okay, we are getting cannot save into a non-existent directory. Okay, I understood why this is happening, because our path inside this folder, right, and the data folder is outside here. So that's why I create a data folder here. Okay, or let's do one thing. Let me import the OS, because every time we have to do that way. Let's not follow that way. Instead of that, let's do that one thing. OS dot make directories data comma exist okay equal to true. So what this line does, it will create a data directory if that is not at all exist. If it is exist, it won't do anything. If it doesn't exist, it will create a new data folder. Okay, so I think we are good here. Now let me rerun the code. We should not get any error now. Yes, and as you can see, things are running. You see, it is creating a new experiment because EXP2 does not exist, right? See, first run is completed. Can you see? See, second run is also completed. So like this, 30 times this run will happen. And once this run is done, then we will see how we can compare the accuracy of the model based on these different parameters. Then we decide that, okay, which parameter we should go for, right? So I will fast forward this part because this part may take some time. So I will fast forward this part and then I will show you once this code is completely run. Okay. Okay. So as you can see that all runs are done. Now if I come back to this one, right, and if I refresh the screen, can you see this experiment 2 is here? And if you click on this one, can you see this many experiments, this many runs are here under this experiment 2? Now let's compare all the runs. See, inside each and every run, things will be same that I have showed you in the previous videos. But now I will show you how do you compare, how it looks like. If I select this, I will select all the runs and I will compare it. Can you see, guys? So now it's visually understandable, right? That okay, how it actually looks like when we run multiple testings, right? On multiple parameters. This is a parallel coordinates plot. See, that is showing you. Let me keep R2 also. Let me remove ME as of now. Okay. You can change the matrix values here, and I am keeping only random state. Okay. So can you see? This is my N estimators. This is my R2 score. So for, can you see that as we increasing the N estimators, our accuracy, the R2 score is going high. Can you see? For this, our accuracy is like this point. Okay. But for this, see, for 5, it's going almost more than 80%. And as we are increasing the number of n estimators, our model R2 score is going so high. Now if I do this testing only for random state and if I remove n estimators, okay, it's like same behavior, right? And if I add both of them now, okay, so can you see, this is the random state, this is the n estimator. Why this is a straight line? Because see, random state and n estimator is the same value in our scenario, because I was running a loop in a zip format. I was taking 1 1 2 2 3 3 like this way. So that is why it is a straight line. There is no changes here. But now from here, our accuracies are getting changed, right? And because of that only, our these lines are different here. Now based on this n estimators and random state, our R2 scores are coming like this way. Okay. Now let's come to the scatter plot. So this is the n estimators and this is the MAE. In the x-axis we have n estimators, in the y-axis we have MAE, right? Can you see? Instead of that, let me show you for R2 score. Okay. So this is the n estimators and this is the R2 score. As we are increasing n estimators, can you see accuracy is going so high? Even see, even for this one, from random for n estimator 3 and random state 3, our MAE got 5.407 and R2 score got 0.816, almost 81%. So as we were increasing the number of estimators, our model was performing really well. Can you see, for this one, for n estimator 11 and random state 11, we got MAE value 4.754 and we got the R2 score almost 84%. So like this, you will visually understand that okay, which one is working well, right? If I come into box plot, let's put some in the box plot. Let's see n estimators and y-axis. Let's put R2 score. So we can get like this kind of visualization, but in that scenario, box plot may not be important, but it depends on your use case, how you are using it. Okay. If I come inside contour plot, can you see? These are the contour plots are getting showed to us here. Okay. So this kind of visual understanding you will get once you run multiple experiments, and that feeling I wanted to show you guys, so that you will get the understanding that okay, this is how it looks like when I do actual runs, okay, under one experiment. Now your task will be, you rewrite the whole code, okay, you rewrite the whole code for multiple experiments. And now your code should be able to create multiple experiment, and under each experiment it should be able to create multiple runs. That's the task you need to do, and then I want you to see by yourself that how things are getting changed. Okay, and if you are getting any issues, don't forget to reach out to us. Okay, fine. Now if we come back to our code, things looks really good to us, right? Now what I do, I will show you something called Autolog. So what is Autolog? First let me go to my edge and let me show you what is Autolog. So is there any definition they have provided on Autolog, or I can explain to you what is Autolog? Okay, let me explain. See what Autolog does. If I come back to my code first, see, in our scenario I was creating some metrics, I was creating parameters like this, and then I was logging it. But do you think it's feasible? Okay, if in your case, if there is like multiple parameters, multiple metrics, you need to rewrite like this, right? Some metrics you need to rewrite, some parameters you need to rewrite, these things you have to do, then you can do it. But it may not be always easy for you to do. In our scenario, it's like very small case, that is why we are able to do it. But it can be the case that cannot you cannot log all the metrics, you cannot log all the parameters, right? And that is why Autologs comes up. What Autologs does is, it try to log everything by himself. It understands that okay, what it has to log. See, this is the MLflow Autolog method that Autolog method that we need to call. Okay, this Autolog method that only we need to call, and these are the parameters that it provides. Okay, log input example, log model signature, okay, log models, log dataset, log traces. What these values are, if you come below, there is the explanation. Log input examples. If true, input examples from training datasets are collected and logged along with model artifacts during the training. If false, input examples are not logged. Note, input examples are MLflow model attributes are only collected if log model is only true. Next is model signature. If true, model signature describing model inputs and outputs are collected and logged along with the model artifacts during the training. Okay. Log models, that will log the model. Log dataset, that will log the dataset. Log traces, it will try to trace the logs. Okay. Sorry, log the trace. Okay. Then exclusive, silent, exclude flavor, this kind of parameters we have here. You can always come back to this definition. See guys, you cannot remember everything, right? That is not at all possible. So every time you can come into this documentation page, you can read it out and try to understand that which one is useful for in your case, right? Okay. So now see, in the case this log input example, that will log the inputs. Okay, input example will log it, that is by default false. And we will run this code now by making this one true. So we want to log the input examples also, and model signatures are already logged here as a true. It will automatically log the model signature. What is model signature? Model signature means model information. Okay, it's just like that only, you can think of. Okay, on the high level. Now log models, now it will log the model itself. And I think you can recall, right, what it is telling, that this model signature only work if this log model is true, because this is dependent with this. Now if you are not logging the model, how come you will get the model signature, right? You can't get it, right? And that is why it is required. Next is log dataset. We will try to log the dataset also. By default it is true, so I don't have to do any changes in the parameters. Okay, and let me do it now here. Okay, fine. Now one thing that you have to note, guys, let me explain what that thing you need to note. Let me show that. See, when you do this logging thing, right, you please make sure that you implement this logging code before this fit, because if you run this code after the fit, na, it cannot track the dataset, it cannot do the logging properly. Okay, and that is why you have to call this auto log before fitting the model. Okay, so I'll call it before fitting the model, MLflow.autolog, autolog. Then model parameters we had this log input example. I'll just copy it, I paste it here, I'll make it true. Okay, I don't think I don't have to do any other thing to be true. Others are already true, so that is not required for me. In our scenario, it's okay that we can do MLflow autolog, and now MLflow autolog and this log input example as true. Now what I do, I will try to comment all of this. Okay, let me do one thing, let me not do it here. Instead of that, let me create a new file, because or else you guys may get confused while doing it. So let me just copy this whole code and I'll do it in a new file so that you can later refer it. MLflow autologging.py. I'll refer the same one. Just I will add here MLflow.autolog, alt tab. I'll just copy this one, alt tab. I'll paste this one, equal to, make it true. Okay, so our MLflow autolog came as true in our scenario. So now what I do, I'll try to comment all this. Because these things are not required now, because things will get locked automatically in our scenario. Correct? That means we don't have to do anything else. We should be able to log things properly. And now, if I go back to my this one, okay. See, right now I have experiment 2, right? And I just don't want to do in experiment 2. So what I do, I try to change my code. Okay, I create a new experiment called experiment 3, and there I run this whole code. so that I'll understand, right, that things are working well or not. And now I don't run 30 times because now it is not required. I run it only 5 times so that we can see if things are getting logged or not. That's our main goal right now. In the previous one, our goal was to understand if we run many runs under one experiment, how it looks like. But now it is not required in our scenario, so I'm not doing it now. I'm just running it 5 times so that it should be able to log all the parameters. And you will see some good magic also now. Okay, I'll show you what kind of magic I'm talking about. If I do Python MLflow autologging.py, the code is running now. Yes, see, experiment is not there. That means it will create a new experiment called experiment 3. And now see, okay, I think let it run first, then I'll tell you what is the issue. Yeah, okay, so things are getting run properly. And if I now come back to my this one and come here and refresh this whole screen, you can see experiment 3. If I click on the experiment 3, I can see the run the dataset also, right? Now if I click on any experiment, let's keep on this experiment. Okay, now I am in this experiment, right? This traveling mare 2441. And if I click on the dataset, can you see it is saying the dataset is an array. To see the preview of the dataset, view the dataset in training node. Okay, so you are not able to see the dataset, right? But I'll tell you why. But now let me show you something. If I come into artifacts, if I click on this input example.json, can you see we are passing this kind of inputs in our model. Now input examples are also getting logged in our scenario, right? So our input examples are also getting logged, and this kind of inputs are going in our model. Okay, but our dataset was not like this, right? Our dataset having some columns and all. See guys, this is the because of scaling. We are doing standard scaling, right, in our code. As we are doing standard scaling in our code, that is why these inputs are showing like this. Okay, that's the issue that I have told you while running that code. And if I come inside model metrics, you can see the things are getting logged here. These values. Okay, come in the overview again. If I come below, can you see this magic? Bootstrap, CCP alpha, criterion, max depth, max features, max leaf nodes, max samples, all values are getting logged now. In our scenario, we were logging only the parameters that we were changing. But by default, this models contains these parameters also. And this value provided by default. These are all the default parameters. Now, in our scenario, we were not logging them, right? Previously we were logging only n estimators and random state. And because of that only, we were having logs only of those two parameters. But now because of Autolog is logging everything. That's the magic I was talking about. It was logging everything. And not only that, if you come in the metric section, see MSC, MAE, R2 score, RMSE, training score, all are getting logged. But in our scenario, when we were doing that, we are only doing R2 score and MAE. We are not doing this mean square error, RMSE or training score, right? So we are getting everything here now. I hope you guys are getting my points now. Why I told you Autologs is really useful. But now let's go back to our code and let me do some more changes. Now to show you how input examples are getting showed by the MLflow, because that input example that is showed by MLflow right now, it is not at all understandable because data was scaled. That's why. So now what I do, so I create another py file for you because I want this also saved somewhere so that you guys can refer it later. Logging without scaling, without data scaling .py. I'll copy this whole code now. I'll paste this whole code now. Same thing will be there, but I don't do scaling now. I remove the scaling part here. I don't do scaling now. I create a new experiment called experiment 4 And what I do, I change this extend scaled. I write extend only. And instead of x test scale, I run x test only. Now what is going on? We have x test, we have x train, so no scaling is here. That means we should be able to see things properly now, right? So now if I do CLS and if I run this code, now not run this code, MLflow auto logging without data scaling.py. Let's see. See, it's again running. See, experiment 4 does not exist. Okay, and you can ignore this warning as of now. Okay, it's like telling infer schema contains integer values, missing values. It's like basic warnings. You can ignore this kind of warnings. Okay, so see, it is running this casual car 5 times. It will run again. Okay, so let it run 5 times. I think it's the last time it will run. Okay, it ran successfully, right? I do CLS, and if I come back to our code now, and if I am in the experiment page now. Now if I go to this artifact section, if I click on the input example.json, can you see now things properly? These are the columns we had: gender, race, ethnicity, parental level of education, lunch, test preparation scores, reading score, writing score. Now this kind of input example we can see, and now it's more understandable, right? On that time we were doing scaling, and that is why we were not able to understand things, correct? So this is the how it looks like. And if we come in the model matrix, we should be able to see the same thing. Now if I come in the artifacts, not artifact, if I come in the overview section, if I click on the data set, can you see what this data set contain for training and the evaluation? For training, this can the data set contain gender, race, ethnicity, parental level of education, test preparation course, reading score, lunch, writing score, etc. Same for the evaluation also. And we have number of rows 200 and number of elements I think 1400, and same for number of rows 800 and number of elements are 5600, right? So these kind of values are here in our case. Now before ending up this session, let me tell you another one is called MLflow.sklearn.autolog. Okay, so see, this is the autolog for any kind of a model, any standard models, but for specific to some other models also they provide some sklearn.autolog. So this one will log only sklearn based models, scikit-learn based models. It will autolog, and it has almost same parameters except few of them such as log, post training metrics, maximum tuning runs. If you do hyperparameter tuning, how many times the tuning should run? Okay, serialization format. What kind of way we can serialize our dataset? So this kind of format and explanation of each and everything mentioned here. Okay, everything is mentioned here, as you can see. Everything in details is mentioned here. Okay, so you can try this one by yourself, because this is the same way you have to do. Instead of call MLflow.autolog, you will have to call MLflow.sklearn.autolog. Okay, same thing, nothing different. Now if I show you some more thing also, see, there are others also there. MLflow.qai, MLflow.qai. Can you see? This QAI is a like agentic. Like if you know about agentic AI, you can build an agentic AI solution using QAI. So QAI is one of the framework. Okay, so you can use QAI also in MLflow to do the auto logging also. If you want to log XGBoost model, you can click on this MLflow.XGBoost, and you can do XGBoost models auto log also. So for every model type only, right? Standard model types, MLflow have their own capabilities called auto log. So you can come in the documentation every time. You can edit the documentation. This is MLflow.XGBoost.autolog, MLflow.sklearn.autolog, whatever is there. You can come in the documentation every time, and you can refer this one, and you can do the autolog. But in the nutshell, the things I have showed you in the autolog will be the same. It won't be changed. Only few parameters may differ based on the model requirements, model parameters. Those basic changes will be there. Apart from that, you won't find any difficulties to understand and to use this autolog. So today we have completed the MLflow tracking section. Okay, so MLflow tracking section is done as of now. So we will start with the model component inside MLflow from our next section onwards. And once this MLflow whole content is done, right, like whole lectures will be done, we will have some one end-to-end ML project. Okay, there we will introduce or not introduce, we will use all these kind of methods, DBC, MLflow, Flask, whatever we have learned, right? We will build some end-to-end project. But we don't do deployment there. I don't introduce any cloud there. I'll just show you how you can build some end-to-end project without the deployment, without creating any other CI/CD and all. Nothing will be there. Just I'll give you the idea that how you can start with any end-to-end project. And once we will complete this MLOps, not the MLOps, this MLflow, some basic projects and all, right? Then we will definitely teach you AWS, and inside the AWS only, we will do CI/CD also using GitHub Actions and using AWS developer tools also. So stay tuned, guys, and I hope you have understood whatever I have explained to you. So let's meet in the next lecture. See you till then. Bye.